Hiya guys, and welcome back to Ace Workshop. So, we did the flywheel last week, crankshaft this week, so I think no messing about, we'll get straight on with it. I didn't have a suitable piece of material, so we had to make something up, but I'll show you all that. So anyway, enjoy guys. Cheers now. So, I put the two little grub screws in, M3s, two of them at 90 degrees to each other, and I've got the little pulley mounted up on a bit of 8mm silver steel, so just chamfer the end on. So I'm just going to face this pulley down now to 13mm overall. As it's, I think it was 16mm to start. So I've set the silver steel back a bit. I think I'll just about get away with it. Yeah, we'll be alright. Yeah. Okay. So I put a pair of outside calipers in the gap in the frame between the flywheel and the other bearing with the flywheel on there, and it came out at 13.1. So I'm going to try this at 13mm just to have a bit of end float in there. We don't want to have it all bitty, there's no point. Ooh. I'm about to hit the end of the silver steel, I think. That would be 12.97. Just got away with it. So, what was that fell over there? Tool holder. Swap to a chamfer on there, I think. No point in having that shoulder on there sharp. Okay, I've got a little Allen key. Loosen that grub screw. I had some grub screws, M3x3, which was short enough. Okay, well, I think that pulley should be good now. Yeah, so there's one grub screw. Hang on, would have gone the wrong way, wouldn't I? So there's one there, and one there, and when the grub screws are tight, they're down below the root of the tooth bomb, so that's good. So, that worked, and there's just a little bit of end float in there, so we're not binding out on the shoulders of the bearings. I haven't screwed it down, and obviously the crankshaft isn't made yet. That's just a piece of the raw stock silver steel. So I'm going to have to look at belts, see what I can get. That's going to be this pulley. It's probably going to be in that way round. I'll have to skim it down to the same size as this one and come off a datum of the inside face of the bearing when I do that bit. And I'll have the two pulleys in line. Now here, let me just swing him around. Okay. So initially all the gears were tucked in here. And that would have been the pivot point of basically the seesaw. So a pivot point here, and obviously the cam would have been back in here somewhere, and it would have rocked on that pivot point, and it was equal length. The pivot point was in the center, and the cam would, or the rocker arm would lift the exhaust valve up here. Okay, so that said, I mean, I can tuck that in there, but obviously I've got to have the cam behind here, so that would be a pain. So I want to be outboard, so here somewhere, maybe around that position, which is very similar to the pivot point, which would mean just half in the length of the rocker arm. Obviously this needs to be up just slightly off the ground, because I don't want it rubbing on the base. I could always do a nice scallop in the base, but that's for another day maybe, if I want to lower it down. So it's going to go this side, in here somewhere. Let's see if it'll stay there. It will. There's going to be a plate here with a bearing, a shaft going through. This pulley will be fixed to that shaft, but it will have grub screws on it, so I can adjust the timing. Shaft will go through into a bearing in this side, so I'm going to have to look, see how high I can possibly put it without breaking the bearing at the top. Should be fine. Yeah, should be absolutely fine. And obviously then its position this way will be determined by what length belts I can get, and obviously it'll have to be far enough away from the pulley that the cam, when it's rotating here, is not going to foul on the flywheel, call it a pulley, on that the cam, which is fixed on the other end of the shaft, is not going to foul on the flywheel. So a few little things to consider. Getting a height is easy enough. I mean, you know, basically whatever the centre line of that is, maybe up a mil would do, or yeah, maybe up a mil would do. I can always put a scallop underneath to get the belt on and off, or pre-fit the belt. Again, I can use an idler pulley between the two on the lower face, down in sort of this area somewhere. Perhaps a little arm with a pulley on it that can be rotated up and locked with a screw. That would be really simple. I'll have to get oh, I have got a needle roller bearing I could use for that pulley. Yeah, so I think what I need to do is look at what belt lengths I can get easily. I want it to be slack. I want it to be enough for a tensioner on the back. So on the old internet now, have a look what belts I can get hold of, you know, what the sort of lengths are, work out what my centres are. I should be able to get a rough idea of what lengths belts will work. Yeah, so my centres, let's just get a rule. I'm going to go very approximately here. So my centres will be approximately 70 mil. If I said 70 mil is a nice round figure. So theoretically, I'd have, I know we're very rough here, obviously it's different. We'll be talking about, yeah, we'll call it 70 mil. So it's going to be 140 mil for the two straight pieces, then halfway around that pulley and halfway around this pulley. So yeah, I can work that out. There are calculators for it. So maybe I'll have a look, see if I can find the easy calculator, get that bit right maybe. I do want to have it so that there's slack in the belt. I don't want to make it size for size what it should be nominally for the right length belt. I don't want to go down that route. I want to put a follower or a tensioner in it. Yeah. Okay, so onto internet, find out what belt I can get, and get a belt on order. Probably get two. Maybe I can get two sizes. I'll see what the range is. I just did a quick working out. Got the calculator here on the DRO, and if I go for somewhere between 70 and 80 mil centres, which is sort of my range, 214 I worked out roughly the belt length at 70 mil. So if I added another 20 mil centres, just nominally 20 mil further apart, we're looking at anywhere between 214 and 234 for my belt. So I suppose if they do a 220, that'd be somewhere in the ballpark. So I got a slug of steel in the chuck here. Let me stop, let me try and explain. I needed a piece of stock, 1.820 diameter. I didn't have anything that big. I think 1.7 was as big as I had. So I got a piece of square plate, knocked the corners of it on a saw, as you can see, or with a grinder, as you can see, sawed the corners off. Put it up in the 4-jaw, got it roughly central, turned a plain diameter on the back, you know, any diameter that would fit in the 3-jaw, and then I've turned it around, put it in the 3-jaw. So I've turned a diameter here of 1.8 inches. And then half-inch diameter in the middle, 31 thou step, which is about to happen. So I'm at 31, I've got a 0. This is just mild steel. I'm going to have an 8 mil reamed hole in the middle, and that will be my last stop on my lathe, I think. That should be it. Okay. Yeah, I was sort of scratching my head thinking how I'm going to go about it, and forgot to turn the camera on, all the rest of it. But yeah, so the OD here is a guideline for the rotary table work. There's going to be some angles on here. So this is the actual crank on the end of the crank shaft. This will be the crank. So I've decided, I've gone away from drawing, and it's going to be a counterbalanced one. So again, thanks to Matty's workshop for the drawing. I did I did get the drawing off Matty, but previous to getting the drawing, I actually did a photograph of his drawing on his video on making this engine. So go and check out his video as well, guys. So yeah, 1/2 inch on there, 34 thou deep, well, 910 radius, 1.820 diameter. You know what? Can I just put a chamfer on there? I will. How am I going to get in there? Let's have a think. Yeah, I'm just going to put a tiny chamfer on the top of there. Nothing really, just a break edge. What have I got? If I put that tool in there, swap him round the other way. Have I got the right Allen key to hand? I have. Ball-ended Allen keys in grub screws is never a good idea. Yeah, there's quite a lot of load on grub screws, and the hexagon is disproportionately small in a grub screw in comparison to the thread diameter compared to an Allen bolt. So quite often you'll find that the let me just check for a fouling condition here. Quite often you'll find that the you'll wear out the hexagon in the top of the grub screw, or alternatively, slow down a touch, you'll find it'll slip round on a ball end instead of gripping it, which damages the grub screw further. So yeah, I tend to change grub screws fairly often if you're going to be using them a lot, like you would in a tool post. You know, it's not a one-use job, a grub screw in these sorts of situations. Just a little break edge on there as well. Okay, well, I'm happy with that. So I can pull it out the chuck. I'll see if I can bring it to camera. So, yeah, I cut it out roughly. I scribed a line, or put a centre mark on, scribed a circle, you know, just where the rough circle was, cut the corners off it. Put a rough circle in using the 4-jaw, holding it in the 4-jaw on these two and these two faces. Put that rough circle on, then I can turn it around, put it in the 3-jaw and do this bit of work here. So I got plenty of spare material, but there's all sorts coming off this yet. So I'm not worried about that. All the rest is going to be done in the milling machine. Rotary table next. I actually shouldn't have taken that out of there. I've just messed up. I meant to put an 8mm reamed hole in the centre first. So I'm just thinking to myself, will it centre back up? Let me see. I tell you what, I'll do it on camera. Hopefully it will. I mean, it's going to be machined and what have you, but yeah, let's see. I'll know at a glance really whether it's any good. That's not good. Let's have a little wriggle jiggle with it, see if I can get it to sit good. Ooh, that's better. Yes, that's running true. Okay, so now at this stage I will put the 8mm reamed hole in, and that's going to be my datum point, and obviously the offset for the crank will be drilled in relation to that 8mm reamed hole. The 8mm reamed hole will be centralised on this boss, and this OD will be centralised on it as well for the portion of arc that it stays there. Most of it's going to be machined away, as I said. So yeah, drill and ream a hole in there. I'm sure you don't want to see that. I'm just setting up to do this now, and I need a little spacer, and I need a hole in it to clear that 1/2 inch by 31 thou deep shoulder. So 16mm hole straight through this piece of what, 4 or 5mm aluminium. I did put a 1/4 hole in first. Right, I'll deburr that with a noga. So yeah, that's step one. We're going to make some packing and some clamps and what have you to let me bring you over here. So yeah, rotary table up. I've made a little pin with a 1/4 8mm pin. Obviously it's 8mm through the middle here, 1/4 in there. I won't go in. and that's going to be my locator per center. So this plate here is going to go underneath here, and then we might have to drill some holes to be able to clamp it down or what have you. So yeah, that's the plan. So I haven't moved the plate since the last time I used the rotary table, so the plate is still centered on the center of the axis of the rotary table. So as per usual with the rotary table, so that's 29.5, 29.5, about the same. Yeah, we've got to. So lock the table up there, set a 0 in X and Y. We got the middle of our world. So let me just bring that cutter, bring that clock out, get her protected, get her out of the way, get her back in a little bag, safe, back in the box, all nice and safe. Close the box, and where's the wooden box? Wooden? No, cardboard box, back in there. Happy days. That's that clock safe. So I've got a 0-0. So let me just pull that DTI holder out of there. Oh dear me. That must be an 8mm collet in there. Might use an 8mm cutter for this. So plan is, I've drilled an extra hole and drilled a tapped hole and drilled an extra hole in this sacrificial plate. Weirdly, the T-slots in the table on this rotary table don't line up with a 0. You'd expect 0 to be halfway between the T-slots, right in the middle, so you've got it, you know, it looks right. But it isn't. So, well, there's not much I can do about that. So my setup is, the little rebate there sits in that cutout. Let me, as you can see, so clearance there. Locate on the pin. There we go. Put it roughly square to the mill travel, not to the block you can see it sat on. That's it. I've got an 8mm stud going there. So I'm not going to be machining this end till a later date. So just put the little stud in. I've got a clamp. So this is the area on this particular setup I'm not going to be machining. And then a little bit precarious, but I've got, it is still over the table and it's vertical there. I got a little clamp. Let me just see. That looks fairly square to the table. So this plate is square to the table, the travel of the table. The part is, well, these flats are not quite. That looks pretty square. That clamp is heading downhill just a touch. Can I get away with one less step? Yes, that's still running downhill. Tiny bit. So, okay, that is now fixed to the rotary table. So, can you see? Let me have a look. Bring you in a touch. Yeah, you can see roughly where my lines are. So, crankshaft goes here. Crank pin, or big end, I suppose you'd call it. Would you call it that? Yeah, big end. We'll call this the crank, the main journal. The big end will be running out here, 625 offset. Don't know whether to drill that hole at this stage or do it at a later stage. You know what, it might be worth doing that now, just to get that nailed down. I know I'm middle for diddle. If I come across 625, bang that hole through. Now this is going to be the journal's M6 diameter that the needle roller is going to run on. So and it's going to be on this side, it's going to be an M5 hole, is what I'm going to do. And then at a later stage, I'm going to make up the pin with an M6 with a shouldered boss on the back of it, screwdriver slot perhaps, so I can screw it into that M5 hole, tapped in, and lock it firmly. Then I'm going to put a grub screw down from the end here with a hole in the well, like a divot, we'll say, in the M5 thread, with a grub screw down in here, probably M4, something like that, that's going to lock that and stop it rotating, coming undone when the crank is turning. That's my thought on that. I'm sure it'll be okay, but I'm sure there's better ways to do it. I've seen these things silver soldered in, all sorts. I haven't got the facilities here for silver soldering, so I'm doing it my way. Yeah, pretty much as normal. There's a song about that somewhere, isn't there? So, I'm all on centre of the world. I don't know if I can get that pin out. I probably could if I put a mole grips on it. I don't need to, I don't think. Do I? Might be in my way. I wonder if I can get a soft pair of grips on it and pull that pin out of there. I bet I could, you know. Do I leave it in? Do I take it out? Do I do the roughing with it in there? And when I come to finish it, then take it out. I think that's what I'll do for now. So, 2 flats on either side, 40 degrees inclusive angle. So I need to offset 20 degrees this way, bring back to 0, and 20 degrees the other way. So I've got a 0 set on my rotary table. So let's offset the 20 degrees, shall I? Let's just loosen my clamps. I can never remember which way these go for some reason. So 20 degrees. Wrong way. Oh. 10. Should be coming up to 20 now. 0 on my dial. Lock the table again. There's my 20 degrees. Right, so this will put this side correct. So, I am set in 0, 0. That's good. I can undo my locks. Offset the table. So, I can come back to that 0, 0 at any time, and I got my spindle over the top of the pin, or the centre of rotation, everything else. So I'm going to get a cutter up now and start machining this side. I'm going to match my offsets on both sides, and that should give me an equal amount taken off both sides. So, you know, I'll do, like, let's say 20mm offset with a cutter, cut this side off, flick it 20 degrees the other way, take 20mm off the other side, and then measure up and see how much is left. That's the method I'm going to use. So, with hindsight, I can't see the radius intersection point because it's on the underside, and that's the bit with the correct radius. But the drawing shows me that the intersection point of the angles from centre are 7... Oh... Yeah, I'm forgetting the figure off the top without going back to my phone. Anyway, I know that my offset using this 4mm cutter in the parallel form, so I'm 0 degrees here, has to be 883. So I'm going to do both sides down to 883, which is parallel. Then I'm going to wind off in Y, set the 20-degree angle again, and then just keep machining it until the flat bit that I've just machined on disappears on that intersection point, and that'll give me the correct size. 729 I'm thinking, but I'm probably wrong. So I'm on 890 now. Let's go 886. So my intersection point has got an offset in a parallel way of 883. Then I put the angle on from there, let those intersections blend, do the same both sides, and we should have an equal set of angles intersecting the radius I can't see on the underside at the correct spot. Yeah, I've talked about making it difficult for myself, but I started putting the angles on. I thought, how am I going to measure that intersection point? It's a narrow point underneath. Anyway, found a way. And the drawing thankfully did give me that dimension. So 883. That's it. That's the finished dimension parallel. So I'll let that run across there. Again, I'm digging into the aluminium underneath, which is a sacrificial part, so no worries there. I only, you know, 5,000. So I'll let this run across. 883. I need to write that down, because it might be 10 minutes or so before I do the other side. 883 offset. Okay, let's let that run right across. I'm on the aluminium there. Let me just wind off it. Stop the feed, stop the cutter, rotate the table, I put some black marks on the table which are going to give me approximates using the 0. Missed it. 0 on the dial. There's my 20 degrees. Lock the locks. Okay. I did start putting the 20-degree angles on and then realised I'm not going to know when to stop. So I did it as a roughing exercise. Those of you with sharp eyes will notice I reduced the length of that pin. It was just being a proper pain. Okay, so we're at a point now where I can start cutting again. And now I can see the underside now, a little intersection point down under here. Full of swarf in there, but I can see it. So whatever the setting is on this side, that's what the setting will be when I do the other side. So I'll get to that intersection point and I'll know, I'll have a reading, I can flick him round, do the same on the other side. Clear as mud, I know guys, I do apologise. I'll try and explain it when I get close. So it should have been 886. I machined it square till I was offset from centre, I think 729 plus the thickness of the cutter, which was a dimension offset in Y when I was parallel, when I was in on 0 degrees to 883. I messed up. It should have been 886, but never mind, that's nothing. So now I've cocked it round at 20 degrees using the dial on the rotary table, and I'm going to keep milling this flat down, which is what I'm machining now at 20-degree angle, until this intersection point with the flat meets up with a little bit of swarf in that groove. Let's just, there we go, until it meets up with our little one, which you can see right there. Hence you can see why I couldn't see what I was doing, but it was easier just to machine that off. So I'll keep going now, and when I see the tiniest of flats on there, I'll probably stop, and that'll be good enough. So, wire up. Keep going. When I get to that point where they intersect, I'll flick him round on the other side and do exactly the same there. In fact, I'll probably do a flat 883 again, so that we've got uniformity. In case there isn't a flat on the other side and there's a tiny flat here, let's just make it correct. So cut on again, back the other way. And just give it a little bit of oil now and again, a little bit of cutting compound, just to keep the cutter lubricated. And you can see, even in those couple of cuts, where's my little brush? Even in those couple of little cuts, I'm getting closer. Still cutting the aluminium there. Cutting the aluminium all the while. Not to worry about that. It's there to be sacrificed. I'm not cutting into my fixture plate. I'm cutting into my packing piece. I did run a file over the top of it, top and bottom, just to make sure it was somewhere near. Cut on, back the other way. You get the idea, guys. So yeah, I'll finish this cut to that parallel point. I'll bring you back when I get there. Well, the intersection point, that's the final cut. Right there, and that point underneath. Yeah, that's it. So, if I stop there, let me, can I go to the other side out the way? Yeah, can. Let me just undo Y. So I'm written a note of that, 655. I'm just gonna get out through the other side, getting the aluminium out. That's why I'm leaving the cutter running. Okay, so let's just stop that. Get the swarf off my handles so I don't encrust my hands in swarf. Okay, if I go back to 0 degrees now, always go the wrong way. Don't use it enough nowadays. So it should be the next 0 that I come across is there. Lock that. Right, we're back in a square plane. So, I need to machine this now to that 883. Where are we? Should be about 900, I think. Yeah. 897. Just missing that bolt. So I'm going to machine this till I get to 883, which is only actually 5,000 where I am now. My first pass when I thought this was about 900. So that's the square pass. I won't be able to see it this time. No, I won't be able to see anything around the other side there without diving over the top. So I think 880, that is 883 there. So let me just lock Y off a minute so I don't get any creep. Put a bit. So that's the same flat on the other side as that flat is there. Then rotate 20 degrees again, the other way, and go into the reading of 655. And that will give me equal about centre at the right angle at the right depth. Okay, so both sides sent the correct angle, all the right offsets, everything. We'll take those as standard. I worked out what the offset was. I think it was a 239 rad on the end, half a cutter, and the 625 where the hole's going to go, and just machined that end off and just broke those two edges. Going to be a full rad on here, but obviously we'll have to move the whole block over. I'll have to drill a hole through here in the right place. I'll locate off that hole, clock that central on the table, and do the rad on the end of here. That's for another episode. But I do need to put the second hole in before I do anything else. So I'm back on 0. I will put the second hole in. Now, as I said, it's going to be an M5. So what I'll do is I'll probably, thinking on it, I may even put something like a 3mm reamed hole in there. Something like that I can pick up on a pin with. And then I can always pick up on that hole afterwards and open it up and tap it and what have you. So yeah, that's my thinking for that. Once I've got that hole drilled, I can then break the setup down because I can square it back up easy enough. I'm then going to rotate this on its sacrificial pad around 180 degrees, and I'm going to machine the radius on the back edge. So yeah, basically I'll clamp on this end in effect. That's what I'm saying. Spin the part round, leave the sacrificial plate where it is, spin the part round, and then machine the radius on the end because I know the offset of that. So yeah, that's next step. So had enough for today. I'm going to go back up the house now. I'm going to switch everything off, including the DRO. What I've done is I've reset back onto 0, so there's no angle on the rotary table. It's back on 0 degrees. And I've recentered the tool back on 0, 0 on the pin. So I can switch everything off. I've locked everything. When I turn back on, my DRO should read 0, 0 anyway. And pretty much I'm away to go. I've still got the datum for next time I come down the shed. Well, there we are, guys. We haven't got to the end of it, but I've shown you a great deal of the machining so far with the crankshaft. It did get mentioned, or it does get mentioned fairly often, that I don't show enough of the machining. I didn't show a great deal of it on the flywheel. So pretty much this is a bit more interesting than just turning, or, you know, circular objects. It's got a few shapes and forms and features, so a little bit more interest in this, so I'm showing a lot more of the machining. Anyway, that said, thanks for watching, guys. Thanks for subscribing, and we'll see you all very soon. Cheers now.